What's up, everyone? Welcome back to Better Biomed. Folks, today is one of those days when you want to use something and come to find out it's not working. And it's kind of a letdown. See, I wanted to go over some boards to make sure that they're good to go. And I use the microscope to check the ports and stuff just to be sure that there's no physical damage, especially if I have a suspicion that something might have been dropped or whatnot. I'll check around the heavy components. And I went to use my microscope, and the ring light wouldn't turn on. Goodness. So I did the traditional things. First off, I pulled the ring light down and apart because it's had a couple hard knocks. I get it. But it still doesn't make sense because the LEDs themselves are a solid state item. There's no moving parts, and unless I just beat the piss out of it, it's probably not going to be broke. The other thing is sometimes the microscope, when moving it around, strains this USB. Yeah, there are some items out there that still use that USB port. It sucks, but it is what it is. And one of those items that use that USB port is this power supply, and it's an attenuating power supply, so you can adjust the brightness of the light. Simple enough. On the back, you can see I have Velcro because it holds it under my microscope, but I can just barely read 12 volt, 4 watts. So really low output, but 12 volts nonetheless. And I purposely put my labels so they don't block that kind of data because you never know when you're going to use it, like today. So here we go. I've got my Amscope LED 144. And mind you, this guy's live right now. So I can't pull it apart because first you got to remove the knob. Check. No problem. Little flat blade out the bottom. I got it. That's off. It still won't come apart because these noodles, instead of doing a board where everything's soldered from the backside and it just kind of protrudes to the front, they actually had a through panel from the front with 2 lead wires. You can probably barely see, that's why it stood off so far from the PCB. So this guy has got 2 lead wires that reach all the way down, and they're soldered on the back. I have to take this guy here over here to my bench. Mind you, it's still live. I'm aware of that. So if you see me get lit up, I'm still posting this video because it's going to be funny. So here we are. I take it over to my solder sucker. I remove the solder from there. That allows me to separate the PCB. I pull the power switch out, and then because you need something there to complete the circuit, I soldered the power switch back in. And here we are. Just to give you a firm layout, so over here, the AC power comes in. One leg comes over here across F1, this little fuse, right here. And then it goes through this guy right here, which is the full bridge rectifier. And right here is the high voltage main capacitor, okay? So that, when measuring across that capacitor right there, that should tell you if your input stage of the power supply is working. And I would expect to see quite a bit of volts there. And if you don't see anything on that capacitor, or you see it bleeding down while it's on, so now you know to not check the DC side of the power supply, you check the AC side of the power supply. All right? With one exception. That one exception is the full bridge rectifier right here, which, neatly enough, they're all labeled, so you know which pins are going to be the positive, negative, and which 2 are going to be your AC. Well, I measured them, and I got nothing. So, okay, so the problem is in my AC side. Well, if you kind of memorize the topology of this, you can flip it over, and that gives me direct access to all the stuff underneath. No, we're just going to go ahead and leave it at this angle because that way there I can see it, and you guys can kind of see what I'm doing. So over here is my multimeter. First thing we're going to do is we're going to check the input AC voltage, right? Should be the first thing you check whenever you find out a power supply might not be working. Always check the AC input first. Of course I did that first. And you can see here on the meter, my meter is slow, but it is good. I have 121.4 volts. We're good. So from here, I probe the AC side by anchoring one of my leads, and this is a very good point when you have the isolating tip leads, which just leave a little bit of a protrusion. This is where you would use those, okay? Because that way there, you can clip on to something and then you can take your attention elsewhere. So I'll let you guys see right there. We have my multimeter. So I'm going to probe here and here. See, I still have my 120 volts. Now this right here is that F1 fuse. I'm going to touch here. This is the opposite side of the fuse. And right here, that takes me all the way to the bottom of the bridge rectifier. So I know that I have that leg of AC. So what do you do now? Now you switch leads. Now you anchor the other lead firmly to your input and you start probing backwards. So let's see. I have 120 volts there. Goes over a little filter. I have 120 volts here. Right here is that infamous power switch. 120 volts there. I have nothing on the other side of that power switch. So let's go ahead and take a look. It is firmly in the on position. That is definitely on. Okay, let's check it again, just in case. So you see what happened there? I have a finicky power switch. Well, luckily I do have other power switches, and I'll just solder another one in. But that goes to show you folks that most things break where the user interfaces with them. I was expecting either maybe it to be here by the dial on the potentiometer that adjusts the attenuation for the LEDs. But in this case, I have a defective power switch, and that kind of sucks, but not at all. I mean, I have probably plenty other power switches. I can even steal one. That is a generic part right there. So I can get that through panel power switch off of many other items. And obviously, if you guys see my shop, I have many other items to boot. It is what it is. I'll grab a power switch and I'll throw that little bad boy in, and we'll get this guy back and going so I can get back to work. All right, thanks for watching, guys.
If you enjoyed this video, don't forget to give it a thumbs up and subscribe for more content. I'd love to hear your thoughts, so drop a comment below with what you'd like to see in future videos.